Good morning, children. Welcome back to recorded video. Due to this pandemic, we have planned for 2 weeks. Recorded video will be sent to you. This 9 max laws of exponents for real numbers. So far, in number system chapter number 1, 5 exercise already we have finished, and now this is the last topic, and the exercise is 1.6 is there, and this topic is nothing but already you know very well, that is laws of exponents for real numbers. So laws of exponents means, for example, generally take this 5 power 3, 5 cube. So this 5 is a base, okay, and this power 3 we call it as exponent. Clear? So the base is nothing but the number that is small a. We generally take this base as small a, which is greater than 0 and a real number. Clear? So this is the base and the power is 3 here. So we call this 3 as exponent. So the number below the power is base and the number above the base is called exponent. So such type we have to take. So now m and n. Okay, m and n, small letter only. So these are any rational number. Rational number means integer by integer, or simply integer is a rational number. So then we can say the following laws. Some more laws also are there. Just we see now this one. First one, a power m into a power n. You have to read as a power m into a power n, which is equal to a power m plus n. Okay, so we have to observe which is the base and which is the power. Power means exponent. See here in the first one, all the bases are a only. The left side, the two bases are multiplying, whose powers or exponents are different. This is m and this is n. And here, the right side, the same base is coming. And in the exponent, sum of the two powers, m plus n. Clear? So addition of the powers. So a power m into a power n is equal to a power m plus n. Option 2. Second one, a power m whole power. A power m already is there, to the whole power n. So power to power. So you have to write a power m n. That means multiplication of the two powers, that's all. M also exponent is there. Over that n is there. So product of the two powers, that is a power m n. M into n. So we just call it as m n. Option 3. A power m by a power n. So here you see the base is same. The exponents are different, but the two bases are dividing. Clear? A power m divided by a power n. So when you divide, okay, you get a power m minus n. You see, the first one, product of the two bases, the bases, same bases. So in the exponent, sum of the powers, m plus n. Here, division, same base but divided. So you put the base a, the same base a, but in the exponent, you have to write subtract. So m minus n, we have to subtract. That is the difference of the powers. Okay, but the condition here we have to write m greater than n. You know why? Then only you can write m minus n. If n is greater than n, then you can write as n minus n. But a power m by a power n means which is in the top exponent m. So a power m minus n. So a power m minus n. And here m is greater than n, so that you have to consider here m greater than n, so m minus n. A power m into b power m. Look carefully. Here the bases are different, but the exponents are same. Okay, a, b are different bases, but they are multiplying. Bases are multiplying, but the exponents are same. So just you multiply the two bases A into B, you know AB. But put the common exponent for both, because the both exponents are m only. So just to multiply the base A into B and put the common exponent as m. That's all. So these are the beginning of 4 laws. And just we take all these. Okay. So this is the exponents law. And some more laws we will see. You see. So look here, 1 by a power n, 1 by a power n. So in the numerator 1 is there, and in the denominator a power n is there. If you come across such numbers, you have to write a to the power minus n. You see, a to the power minus n, because the base is a, in the denominator the base is a, the exponent is n. When you change the sign of the exponent, then a power minus n, that means the reciprocal 1 by a power n, that is the reciprocal form. Okay, so 1 by a power n becomes a power minus n. So the sign of the exponent, you observe carefully, the sign of the exponent gets changed. For example, you can take an example for this. 1 by 3 square. Then you can write it as 3 to the power minus 2. In right side 3 power minus 2. If you want to write the exponent as positive, here negative. 3 power minus 2 means the exponent is minus 2. It is negative. To make it positive, in the lower classes, you already had come across that 3 power minus 2 means, to express in positive exponent, we will write in this form, 1 by 3 power 2, that is 3 square. So another example, if you take 5 by 2 power minus 3. Then we can write 5 into 2 to the power 3. Right? So the numerator is 5. Leave it. You just write as it is 5. But in the denominator, you see 2 power minus 3 is there, and you know that minus 3 is nothing but the negative exponent of 2. So if you want to change to in the positive exponent, then we can write 5 into 2 to the power 3. So this denominator 2 power minus 3 becomes 2 power 3. Clear? So this is the way of writing, and under this law, 1 by a power n is nothing but a power minus n. So this is the negative form. If you want to change the exponent as positive, then we can write as 1 by a power n. And now you take all this. And now coming to the next one. Sixth law, we take just a power 0 equal to, that is a to the power 0 is 1. It means anything, okay, in the power, but the base is a. For any base a, if the power is 0, that means the exponent. For 0 exponent, for any base, the value is 1. Remember, okay. Example we can give. Example, 10 to the power 0 equal to 1. Clear? 23 to the power 0 is 1. So any number to the exponent or to the power 0 is 1. The next one, you know that how to read this as this n belongs to the nth root of a. Clear? For example, square root of a you can write as a power 1 by 2. That you know. Example this is. Clear? And just I am writing the nth root here. Sometimes you will write here a small size comparing to the number inside the square root. That is radical sign. This is called radical sign. You know. This is called radical sign. So that good symbol. For square root, no need to put the 2 here. But in other roots, for 3, 4, 5 like that, we have to write 3, 4 like that here. Then you have to represent. But for avoid the confusion, just I am writing here. Otherwise, you have to write like this small letter. Okay. Like this also you can write. To avoid the confusion, I am writing this. If you write like this in such a way, then this is wrong. This is you can say 3 into root a. 3 into root a. But this is cube root of a. And this is also we can call it as cube root of a. To avoid confusion, you can write here. Okay, like that I am going to teach you. So this cube root of a you can write as what? A to the power 1 by 3. So this is cube. Suppose the nth root means, so this way. Next one you can take as the 7th one. Okay. Nth root of a you can write as a to the power 1 by n. So this is square root, so a power 1 by 2. And this is cube root of a, and we can write this as a power 1 by 3. And if it is nth root, then we can write a to the power 1 by n. Such a way you have to understand the nth root. Clear? So these are the things. Our numbers if you put, then we will get like this an example. You see this is cube root of 2 and you can write this as 2 power 1 by 3. Okay, these are examples you can take. Okay, take this. And then next. Another example also we can give. Now we will move to the next and we will give example. The next one is, you see, a to the power m by n. Listen how I am reading. This is a to the power m by n. The exponent itself a rational form, p by q form, m by n. So, how to understand this? You see how I am writing. This is a power m into 1 by n. So, like that we have to split m into 1 by n. That is nothing but m by n. And now we can write this as, that's 1 by n is, already I told you, you can write as nth root of a. So like that 1 by n is here. So you can write this as nth root of a, but n is there now. Okay. So for that we have to a power n. Clear or not? Or you can write like this also. Next step we can write what I told you. So this is nth root of a whole power m, like that we can understand. And finally we can write this as nth root of a power m. Clear? Nth root of a whole power m means we can apply power this m exponent to this base a. So nth root of a power m. So all these are same. Clear? So these are the things we are going to apply in the problems. So a power m by n we can write as nth root of a power m. So this 1 by n we have to split like this. Otherwise you just jump to this step from here to here. A power m into 1 by n, like that we can split this. And 1 by n, if the exponent is like reciprocal from 1 by n, then we can write it as nth root of a, and this power, okay, the integer m is there. So we can apply for the base a. So a power m. So nth root of a power m. Clear? So like that we can understand all this. And now we can move to the exercise. So this is a power 0 equal to 1. That means for any base, if you see the exponent is 0, then that is 1. And here n root of a, you observe how I am writing and also reading. N root of a is equal to a to the power 1 by n. Some more examples in the general form with numbers I have given, and here inside the root, the base is also I gave number instead of a, and the last one is a power m by n. The exponent is in m by n, that is rational form. So if you face such a problems, then you can write the base a to the power m by n. You can split as m into 1 by n. But you know, m into 1 by n is nothing but m by n. And then 1 by n, if the exponent is like the reciprocal 1 by n, then we can write this as nth root of a whole power m, which is nothing but nth root of a power m. This m will be applied to the base a. For this we can see an example. Okay, wait and see. 4 power 3 by 2, for example. Okay, 4 the power 3 by 2. You know how we can find this, the solution. 3 by 2 we can split as 3 into 1 by 2. Am I right? You see how I did here? M by n I split it as m into 1 by n. The same way 3 by 2 I split it as 3 into 1 by 2. And now 1 by 2 means that is square root of. You can like that we have it. The second root then nothing but square root. So square root of 4. For that we no need to put 2. If more than 2 means like this we can put 3. And if it fourth root means 4, like that we can. So this is square root 1 by 2. No need to put that. So square root of 4. And this 3 is there. From the base 3 is also there. So you can put 3, 4 cube. And this will be 4 cube means what? 4 into 4 into 4. Am I right? 4 into 4 into 4. So like that we can do. So that's one. Square root of 4 cube. And this is nothing but 64. So 64 whole to the power 1 by 2, like that we can take. Am I right? If you want to find the solution, square root of 4 cube, and then 4 cube is 64. 64 whole to the power 1 by 2. Again the square root we can write in exponent form, that is 64 whole power 1 by 2. Otherwise we can write this as directly 4 cube whole to the power 1 by 2. This is nothing but 64. You see how I am converting. And again 64 is nothing but 8 square whole power 1 by 2, which is equal to 64 is nothing but 8 square, that you know. So again 8 power 2 into 1 by 2, like that we will get 8 power 2 into 1 by 2. We can cancel and you will get 8 power 1, which is nothing but 8. So you see how we are getting this 4 power 3 by 2 as 8. Clear? So this is the way of writing. Clear, children? So 4 power 3 by 2 is split as 4 power 3 into 1 by 2. And you apply that power 3 to the base 4 cube whole to the power 1 by 2. And 4 cube we can write as 64, again power 1 by 2. And the 64 is 8 square, so 8 square whole power 1 by 2. So the exponent you see the power or multiply 2 into 1 by 2. Then after cancellation you will get 8 power 1, and which is nothing but 8. So like that we can have one more examples, or directly if you want you can write in this form also. I already wrote that. So cube root of whole power 1 by 2. So that is also the correct way. Now coming to the exercise. Exercise 1.6. So exercise 1.6. The first sum. Find 64 power 1 by 2. You see, already I told you 64 power 1 by 2 is there. So you can write 64 as 8 square whole power 1 by 2, and this is nothing but 8 power 1, which is equal to 8. The same. Okay. An option 2. You see what is there? Option 2, 32 power 1 by 5. So we have to find the value of 32 power 1 by 5. So 32 means you have to split, or you have to find the factors by prime factorization that you know. So in the column we can put like this. So 2, what? 16, 2, 8, 2, 4, and then 2, 2, and then last 2, 1 something. So this is nothing but 2 to the power 5 whole to the power 1 by 5. And again, you see 5 into 1 by 5 in the exponent. The base is 2. And you see the exponents are multiplied 5 into 1 by 5. That you can apply that law a power m. Which law? A power m whole to the power n is nothing but a power m n. So as per that law, we can write this as what? 2. That's all. 5 into 1 by 5. If you want, you can write. Now the understood, you can write this as 2 to the power 1, nothing but 2. The answer is 2. So like that, you do the homeworks. The third option, 125 whole power 1 by 3, and you know the 125 is nothing but 5 cube, and you will get the answer easily. And coming to the second, sum. So it is there. Find 9 power 3 by 2. Option 1, 9 to the power 3 by 2. So you see, you have to put the equal sign straight to the base. You see how I am writing? Straight to the base only you have to put equal sign, not to the exponent. Clear? So 9 means you can write as by doing the prime factorization 3 into 3. Am I right? So that is 3 square. You see? 3 square is nothing but 9 whole to the power 3 by 2. For 9 I have written 3 square, and then whole to the power 3 by 2. The power same. And now power to the power. So if you multiply 2 into 3 by 2, what you get? In rough form we can do 2 into 3 by 2. What you get? 3 only. So this is nothing but 3 cube, which is equal to 27. That you know, 3 into 3 into 3 is 27. So like that you have to do this. And coming to the next one, 25 to the power minus 1 by 3. Fourth option I will do 1. So what about the other two? Second option and third option you take as homework. 125 to the power minus 1 by 3. 125 to the power minus 1 by 3. So that is the question. So here you have to focus on the exponent which is negative, minus 1 by 3, isn't it? So how to do this? So 125 power minus 1 by 3. So for this you have to take another one. step, the law you have to apply here is 1 by 125, okay, power 1 by 3. You see how I have written? You know, a power minus n, you can write as 1 by a power n. Alright? A power minus n, whose exponent is negative. So we can write as 1 by a to the power n. That is changing the negative exponent to positive. So then only we can apply that exponent, okay, to the base. If it is negative, we know any idea? We don't know. Okay. A power minus n means the negative exponent we cannot apply to the base. So change to the positive exponent. So a power minus n becomes 1 by a power n. If we take reciprocal, then the sign of the exponent will change. So now it is changed into 1 by 125 whole power 1. Now 125 means 5 cube. You do that prime factor system. Okay, 125. So 525 that you know, and 5 1. That's all. 5 25 are 125. 5 5 are 25. Again 5 1 is 5. So 5 cube. So you can write this as 5 cube whole to the power 1 by 3. You see, part 125. I am writing 5 cube by doing this. Again, whole power 1 by 3 is there. So 5 cube whole to the power 1 by 3. And now, nothing but 3 into 1 by 3. The power is multiplied. Power to the power 3 into 1 by 3. Then you can cancel and you will get 1 only. So this is nothing but 5 by 1 by 5 power 1, that is 5. 5 power 1 means 5. So that's all the answer. You can write in one step, one more step using that 1 by 5. So this is the final answer. Now coming to the third question. Third one, simplify. So you have to simplify. Like one question, the first option, 2 to the power 2 by 3 into 2 power 1 by 5. So this dot represents multiplication. Okay. Now let us see how we are going to do this. First of all, you have to focus on the base and then experiment everything. Here the bases are equal. Here the bases are equal. So for the same base, the power you have to add, because the bases are multiplied here and the bases are same. Therefore, we have to put the base common and the power you have to add. So 2 by 3 plus 1 by 5. So which law is applicable here? A power m into a power n is a power m plus n. So by applying this law here, so we can write this question as list. This one we have to simplify. You know how to add the what? Fraction and fraction, or rational number and rational number. So we have to take LCM. 2 by 3 plus 1 by 5. So denominators are 3 and 5. So you know that LCM is 15. If you want, you can write in the right column. That is 2 by 3 plus 1 by 5. The LCM is 15. So this is 3 into 5 only. If you multiply 5 with 3, then only you get 15. So if you multiply the numerator also, the 5, what you get? 10. And then plus 5 into 3 is 15. In the second one, 1 by 5. The denominator is 5. So to get 15 equal to the denominator, 15 here equal to the LCM. Okay. 5 into 3 is 15. So therefore, you have to multiply the numerator also by 3, then you get 3. And this is nothing but 30 by 15. Okay, so this is the way of doing, and you know that how to do this one. So it's a simple one. So here I am writing like this. 15 is the LCM, and 3 into 5 is 15. Therefore 2 into 5, 10 plus here 5 into 3 to equal to the LCM 15. This 5 should be multiplied with 3. So 5 into 3, 15. Therefore 1 into 3, 3. And the next step you can write this as 10 plus 3, 13 by 15. That's all. Okay. The answer for this one is 2 to the power 13 by 15. Clear, children? And now the next one, 1 by 3 cube. 1 by 3 cube whole to the power 7. You see. So these are the things there. 1 by 3 cube and then whole to the power 7. So this equal sign you have to put straight to the wall. Okay. And now, how to do this? This is like 1 by 3 cube means the denominator has 3 cube. So it is better to write this as 1 power 7 by the denominator whole to the power 7. So this is common power. The base, the numerator is 1 and denominator is 3 cube. So you can apply the common power 7 to the both numerator and denominator. So this is 1 to the power 7 by 3 cube whole to the power 7. The common power is there. So you apply separately for numerator and denominator. Then what you get? 1 to the power 7 means 1 to any power 1 only. So you get 1 by here in the denominator 3 cube whole power 7. So power whole to the power into power. So what you get? 3 to the power 3 into 7. Am I right? So this is nothing but 1 by 3 power 21. Clear? And if we want this as in the straight form without the numerator and denominator, then we can write this as what? 3 to the power minus 21. Already I told you, this is already in the denominator, the exponent is 21, it is in positive only. Suppose if you want to write in this form, this is fractional form, this is nothing but in the straight form, integer form. So you have to change the sign to the exponent. Now it becomes 3 power minus 21. So here you know how you are applied 1 by a power n, you can write as a power minus n. That's all. Anyway you can take. So this applied here from here to here. Okay. And this is, you know, a by b whole power m. This is 6 means there is a reason. M means common power for numerator and denominator. Then you get a power m by b power m. So this is the way you are writing. So applying this is correct. And then next step 1 by 3 power 31. To write in this form, if you want, then write as 3 power minus 21. And coming to the next question is option 3. You see 11 power 1 by 2 by 11 power 1 by 4. So in the numerator 11 power 1 by 2, in denominator 11 power 1 by 4. So you just see here, in both numerator and denominator, the bases are same. What is that? 11. So here the base is 11 and the denominator also base is 11. So for the common base, am I right? The powers are different. Anyhow, You know that law a power m by a power n is nothing but a to the power m minus n. So as per that law, you can write this as 11 to the power 1 by 2 minus 1 by 4. Am I right? And now 11 to the power 1 by 2 minus 1 by 4. So you have to simplify this 1 by 2 minus 1 by 4. It's nothing but taking LCM only. And in short way, we can say half minus quarter. Half minus quarter means quarter only, that you know. 1 by 4. So this is a very simple one. Okay. So simple calculation we can do the direct method. Better way. Half minus quarter is nothing but quarter. So 11 to the power 1 by 4. That's all the answer. And then the last one, 7, option 4, 7 power 1 by 2 into 8 power 1 by 2. Okay, here the bases are different but the powers are same, that is exponents are same. So we have to write a into b, that you know the law a power m into b power m is nothing but ab whole power m. Yeah, the bases are different but the exponent is same, so you can apply this law. So now I am writing this as 7 into 8 whole to the power 1 by 2. And what will happen? 7 into 8 is 56, so 56 whole to the power 1 by 2. So like that we can write. So this is the way. We cannot simplify this further. Okay, just do it. 56 whole power 1 by 2 is the final answer for this question. So like that we have finished all the sums in the exercise 1.6. And now some extra sums we will see. Clear? Dear students, now let us see some extra problems. First sum, find 2 power 0 plus 7 power 0 by 5 to the power 0. You see, in the numerator and denominator, the bases are different, but exponents are 0. You know, anything power 0 is 1. By applying this exponent law, it is very easy to find the value of this. So 2 power 0 also 1. Be careful. The power is 0. Therefore, 1 only answer. Plus 7 power 0, 1. By 5 power 0, that also 1. So in the numerator, 1 plus 1 becomes 2. And denominator 1. So 2 by 1 is 2. That's all. Clear? So this is the way of doing this. Remember, any number to the power 0. Clear? This 1. And now coming to the question number 2. Find square root of 3 power minus 2. So this is the first step. And solution, square root of 3 to the power minus 2 is equal to, this is square root. Square root means, you know, the radical sign is there. Square root, why you are saying no number is mentioned there. If it is 3 here, then that is cube root. If it is 4, then 4 root. If it is n, then n root. But you know already we have discussed everything. So this is square root of 3 power minus 2. Square root means in exponent form we can convert to whole power 1 by 2. This is square root form. And if you try to convert to the exponent form for the 3 power minus 2 whole to the power 1 by 2. You have to write like this, that you know. Am I right? So square root of a is nothing but a power 1 by 2. Square root, if it is nth root means, then we can write as a power 1 by n. So this is the common thing that you know. and this is square root, so whole power 1 by 2. So what is inside the square root? 3 power minus 2 to the whole power 1 by 2. Why we have written 1 by 2 in the whole power? Because it is square. Clear? So now 3 to the power minus 2 into 1 by 2, and you can cancel 2 and you will get 3 power minus 1. So 3 power minus 1 means easily you can write as 1 by 3. That we know. A power minus n is equal to 1 by a to the power n. That we know. So applying this, we can write a power minus 1 as 1 by 3 is the final solution for this root 3 power minus 2. And coming to the third question, find x power a minus b into x to the power b minus c into x to the power c minus a. So the bases are equal. That means same base, x, x, x. So you have to understand the question by observing carefully. That is very important in maths. And whereas the exponents are different. Here a minus b, here b minus c, and here c minus a. So this is into multiple symbol. Clear? And in the solution, you see what we are going to do. X power a minus b into x power b minus c into x power c minus a. Clear? Which is equal to the same base is multiplied. How many times? 3 times. 1, 2, 3. Whatever the time multiplied the same base, you put the base common and you add the powers by applying the law. Which law? A power m into a power n is equal to a power m plus n. So suppose if it is multiplied again as into a power p. For example, if you write a power m into a power n into a power p, what you get? A to the power m plus n plus p. So like that we can proceed for the same base, the product of same bases. So here the base is only x and you add the exponents. A minus b plus b minus c plus c minus a. You see, I put bracket for every exponents to avoid confusion. And here addition only, because we are going to add the powers for the product of the same basis. So now we can remove the bracket and write as a minus b plus b minus c plus c minus a. Now it's very easy to get the answer. You see here plus a minus b and minus b plus b gets cancelled. Minus c plus c gets cancelled. For what will be the remaining? So nothing is there. Everything is cancelled. Therefore you get 0. For example, you can write 3 minus 3. What you get? 0. By cancelling, you can say 0. Like that, everything is cancelled. So you get 0 in the exponent. So x power 0 means that we know already anything power 0 is 1. Any number to the power 0 is 1. So here x is the number and whose exponent is 0. So the answer is 1. Simple. So like that we can find the answers for different questions. These are some extra questions. So previously asked questions in the CBSE papers. Okay. So we make it thorough and take the notes then and there. Okay. So now one more problem we will see. And now we can see one more sum. So before seeing that sum, just we come to this another property in exponent law. A by b whole power minus m. You see the bases, in the base the numerator is a, denominator is b. The whole thing a by b is the base whose exponent is minus m. So negative exponent. Okay. A by b is the base whose exponent is minus m. So you have to read it as a by b whole to the power minus m, which is equal to b by a whole to the power m. So how's that? You see, I will explain this. A by b whole power minus m, we can write as a power minus m by b power minus m. Okay. Now a power minus m, if you take reciprocal, what happens? Simply if you write a power minus m into 1 by b power minus m, then you will get, can you understand what I am writing? Just I have splitted numerator denominator. A power minus m into 1 by b power minus m. If you want to convert this a power minus m in positive exponent, then we can take it as 1 by a power m into, and this also you see, negative exponent, the denominator is in negative exponent. So if you take reciprocal, you will get b power m. So which is nothing but b power m by a power m. So in common we can write b by a whole power m. B by a whole power m. So this is the way, you know already, a power minus n is nothing but 1 by a power n. Clear or not? And if you have a power n, and if you want to write in the negative exponent, then you can write as a power minus n. So both are same. Clear? Just if you take reciprocal for a base, the sign of the exponent will change. This is the concept. So by using this idea, we can get a by b whole power minus m as b by a whole power m. But directly we can understand that a by b whole power minus m becomes b by a whole power m. That means what? Just you see, minus m becomes plus m. The negative exponent is changed to positive exponent. How? By taking reciprocal of the base. Here the base is a by b. If you come across such base, then if you take reciprocal, you get b by a. And what is the change? While taking reciprocal, the sign of the exponent will change. You see, a by b becomes b by a, and minus m becomes m. So this is the way. So just you take the example only. This is the explanation. Just I am running. Clear? So this is the way of doing this. So this alone you take the notes. And now coming to the problem, find 64 by 25 whole to the power minus 3 by 2. So how to do this? The solution, 64 by 25 whole to the power minus 3 by 2. So the exponent is what? Negative. To convert to positive, just to write as 25 by 64 whole to the power 3 by 2. You see the negative exponent becomes positive. Minus 3 by 2 becomes plus 3 by 2. You know how? By taking reciprocal. 64 by 25. If you take reciprocal, it becomes 25 by 64. That's all. Remember, we are applying this way. And now, you have to find the value for this. 25 means you can write as 5 square. That you know. And 64, 8 square. That also you know. Again, the base. Exponent is 3 by 2. And now 5 square by 8 square. You see the base, the numerator of the base is 5. Here also the denominator is 8, but the exponents are same. So therefore, you know that a power m by b power m is nothing but a by b whole power m. That you know, right? For the common exponent, we can write like this. So this also I am trying to write as 5 by 8 whole power 2 to the whole power. Again the power 3 by 2 exponent is there. So you have to write carefully. Okay. 5 by 8. I am writing as the base 5 by 8. And then the common exponent is 2. So 5 by 8 whole square. You see, here also 2, here also 2 the exponent. So commonly we can write 5 by 8 whole to the power 2. and again the exponent is there, so over there we have to write 3 by 2. So for that I change the bracket, whole to the power 3 by 2. Now power into power, so 2 into 3 by 2, 2 into 3 by 2. What happens? 2 to cancel, we get 3. Alright? So like that we can write here 5 by 8, we can cancel this 2 and 2. Like this I have explained here clearly. So 2 into 3 by 2, you will get 3 only. So 5 by 8 whole cube, like that. So just I am writing here. Then you take this. Okay. Now I am going to write this. The next step here, 5 by 8 whole cube you will get. Am I right? Or you can write as 2 into 3 by 2. 2 gets cancelled, and then 5 by 8 whole cube, and easily you can write the value. What is that? 125 by. You know how I am writing 125? By applying separately 5 cube by 8 cube. What you will get? 125. 5 cube means 5 into 5 into 5 is 125, and 8 cube means 8 into 8 into 8. We have to multiply. So we will get 5, 1, 2. Clear? So that's all. So these are some extra problems, and you go through all this, and I also gave you homework and worksheet also I will send to you. So you do all this, and you have to practice a lot. So this is the pandemic situation. So you have to cooperate us. We are doing more for you, ready to do more for you. So you practice well. Thank you, children.